So 4x squared minus 31 equals 49 is the last one we did. So back of the second page. So square root method is the second method, well, really third method we've found for solving quadratics. First one we went over was solving quadratics by factoring. The second one, the start of this notes, was solving it by graphing. And this is the square root method. Square root method works if we don't have a middle term. We don't have an x to the first power. Or the only x is inside a set of a parentheses being squared. So this here, 3x squared minus 9, it doesn't have a middle term. We don't have an x without an exponent. So we can use the square root method. Now it is equal to 0. We can try graphing it. So we could say x squared, well, it's not x squared. It is 3x squared minus 9 graph. We do see that it crosses the x-axis at 2 points. One of them's close to -2, and one of them's close to 2. But if we look on the table, we do not have an x value listed in which the y value is 0. Second graph. 3x squared minus 9. 3x squared minus 9. So this is the note sheet 3-3. So -9 is the y-intercept. So we don't have any x values listed that give us a y value of 0, so we can solve this technically by graphing, but we'd have to know the decimal approximation and have to know a little bit more information for us to be able to get to it. So we're going to have to solve this by the square root method. Now the first part of the square root method is to get the term being squared by itself. So what's the first thing we would do? So we would need to move the 9. We can add 9 to both sides, because our term being squared in this case is the x squared. That's our squared term. We need to get it by itself. So we would add 9 to both sides. Is the squared term by itself now? So what do we need to do next? Divide both sides by 3, which tells us that x squared is equal to 3. 9 divided by 3 is 3. So now that the squared term is by itself, our second step would be to take the square root of both sides. Now the square root of x squared is x, because the square root and square cancel, equals plus or minus. Anytime we take the square root of both sides, we have to put the plus or minus, because what the term being squared could be positive or negative, because a negative number multiplied by itself is a positive, and a positive times itself is still positive. Yes, we're a day away. Now at this point here, we can simplify the radical. So square root of 3. So we can go second square root 3 is square root of 3. That's as simplified as it gets. So x in our case is equal to plus or minus the square root of 3. So it is crossing the x-axis as positive and negative square root of 3, but that's an irrational number. Square root of 3 is an irrational number, so it does show up on the graph. It just would be kind of difficult to actually find it. Now, if we wanted to, we could plug it back in, say 3 times the square root of 3 squared minus 9 to see if this does indeed equal 0. In the calculator, I can say 3 parentheses, second square root 3, close parentheses, squared minus 9. Hit enter, and it tells us that it is indeed 0. We can do the same thing with negative square root of 3, parentheses negative, second square root 3, close parentheses, squared minus 9. It is also 0. So that's just to check it to make sure that we got the correct answer. Questions on this here? Now again, I've been saying our first step is the term being squared by itself. Because here the only place where x appears is inside the parentheses squared. So we can still use the square root method. We just need to get that set of parentheses by itself and then take the square root of both sides. Well, what's the only thing being applied to our set of parentheses being squared? The 2/5. So if we were wanting to solve this, we would divide both sides by 2/5. And here the 2/5 and 2/5 will cancel, leaving us with x plus 3 squared is equal to, well, we have 5 divided by 2/5. 5 over 2/5 is 25 halves. So we can do that in a calculator. We could have said 25 divided by 2/5, 25 over 2/5. Either one works. And it reduces to 25 over 2. Now we do want to leave it as a fraction because taking the square root of a fraction is a lot easier than the square root of a decimal. Questions on any of this here? Now, is our term being squared by itself? What is being multiplied, divided, added, or subtracted to it? So what's our term being squared? Because isn't this whole thing being squared? So the whole thing's being squared. Now, is that whole thing being squared by itself?
No. Yes.
Yeah, because what is being squared? The quantity x plus 3, yes? Do we have anything added to that quantity? No, we don't have anything added, subtracted from it, or multiplied. The quantity that's being squared is by itself. Because at this point, we can square root both sides, because the square root and square would cancel, leaving us with x plus 3. We're not so much worried about what's inside the parentheses. We're just wanting the fact that that term with the parentheses squared is by itself is equal to plus or minus our square root of 25 over 2. Now, if we're going to simplify this in the calculator, we do have to split it up into the square root of 25 over the square root of 2. If we try to type it in either calculator as the square root of 25 halves, it will convert it to a decimal. The graphing calculator will convert it to a decimal no matter how we put it. So we'll use the 30xs. And the square root of 25 over the square root of 2 is 5 square roots of 2 over 2. So for these here, we'll want to use the 30xs calculator because it's a lot better at simplifying these. Questions on how we got to this point here? Questions on any of this here so far? Is x by itself? So what do we need to do to finish solving this? Subtract 3 from both sides. Now the interesting thing with this here, because normally we would put the minus 3 at the end, but whenever we have the plus or minus, we put the number that we're adding or subtracting from both sides in front of it. So here we would say x is equal to negative 3 plus or minus 5 square roots of 2 over 2. Questions on how we got to this point here? Questions on anything we've done so far? Is -3 and 5 square roots of 2 over 2, are they like terms? Well, no, the square root of 2, because 5 square roots of 2 and 3 are not the same, because they don't both share that square root of 2. They're not like terms. We can't combine them. So our final answer is this right here. Now, if we didn't have the square root of 2, if it just said -3 plus or minus 5 halves, those are like terms. We can add and subtract those. We can simplify. Now, what the plus or minus is really saying is two things. It's saying, one, that x is equal to -3 plus 5 square roots of 2 over 2, and that x is equal to -3 minus 5 square roots of 2 over 2. The plus or minus gives us the ability to say both of these statements in one instead of having to write both out. Questions on this here? We ready for another one? All right, let's look at the next one. 2/3 x squared plus 14 equals 20. Again, we can use the square root method on this here because we do have an x squared term, but we don't have a middle term. We don't have an x term. We don't have plus 3x. So we can use the square root method. So the first thing we need to do is get our term being squared by itself. And we can do that by?
No, wait, subtracting 14.
Yes. It's not so much that it's a mess up, because it is a step we could do. But if we did that first, we would have to divide our 2/3 x squared, 14, and 20. In this case, it would work out that it does give us nice numbers, but it won't always work out that way. So it's sometimes easier to wait to the very end. So at this point, to divide by 2/3. So we did our addition, which gave us 2/3 x squared equals 6. So the last step is getting x squared by itself is dividing both sides by 2/3. So we can say 6 divided by 2/3 is 9. So we're saying x squared is equal to 9. Now what would we do? We'll take the square root of both sides. And the square root of x squared is x is equal to plus or minus 3. And that's it. Questions on this here? Now, if I got it equal to 0, we subtracted 20 from both sides. Because let's say we tried to graph this. I needed to get it equal to 0, subtract 20 from both sides, and we can say y equals alpha, y equals enter, will give us our fraction, 2/3 x squared minus 6, graph. We do see that it crosses the x-axis in 2 places. Second graph, at -3, the y value is 0. Because again, when we graph, we're looking for what value of x will make the y value 0. Or really, when we're solving, we're looking for what value of x will make the function equal 0. We're looking for these zeros. And the other one is 3. In solving, we found that the value of x was positive and -3. So we found the two values. Questions on this here? Most likely no, because we're going to probably run right up into the end of the semester. Yeah, if we do have time, possibly, I don't see that happening because I see chapter 4 putting us right up to the end. Solve the following equation using square roots. We would subtract 1 first. Bless you. This will tell us that negative 2x squared equals negative 7. Yes. Bless you. And what would we do next? Divide both sides by negative 2. Telling us x squared is equal to 3.5 or 7/2. We'll want to try to keep it in fractional form because decimal, taking the square root of decimal is not always best, and neither calculator will give us it in simplest radical form. It'll only give us it in decimal form. Now, lastly, we need to square root both sides. Square root of x squared is x is equal to plus or minus. Now, we do need to take the square root of 7/2. And it's been a while since y'all have had to rationalize a fraction, because y'all did it in Algebra 1, and that's probably the last time you've done that. But in the yellow calculator, we can do fraction. Second square root 7 over second square root 2, which gives us square root of 14 over 2. Well, it actually just stays square root of 14 over 2. Because the square root of 14, we're looking for what number times itself is 14. If we were wanting to simplify that, the closest we could get to is 3.8, possibly. .741 going on. But it's an irrational number. It's a non-repeating, non-terminating decimal. So we can't get the full number because it doesn't quite work. So we leave it as square root of 14 over 2 because that's a nicer version of it instead of the 3 point going on and on and on. But that's the answer. Now, there is a way to check to make sure we got the correct answer, because I can take square root of 14 over 2 and plug it back in for x. And if we plug this into the calculator, this should equal what? Negative 6. So I can grab the calculator, say negative 2, parentheses, fraction second square root 14 over 2, close parentheses, squared, plus 1, enter, is negative 6. We could do the same thing with negative second square root of 14 over 2, close parentheses, squared, plus 1 is also negative 6. So doing that gives us the way to check to make sure we got the equation or got our answer correct. Questions on this here? All right, we're going to do one more of these, then we'll do a few factoring, and then we're done for the day. So looking at this here, we do have a quantity or a term being squared. So we can use the square root method because we also don't have an x outside of that. So what would our first step be to get our term being squared by itself? Unfortunately, we can't distribute the 2. Because we need to get it by itself, so we would divide by 2. And because that x minus 4 is being squared, we can't distribute. We'd have to square it first and then distribute the 2. It should be, I think it's 2 to 3, it's either 2 to 3 or 3 to 4 weeks. But since y'all only took the multiple choice part, it shouldn't take them too long to process all of those. It only takes longer when the written portion is done. In the spring. No, you should have taken it in spring.
Oh, what the crap.
That was required.
Yeah, that's the one that's required by the state. Now, and I know Ms. Kendall and a few others think it's very important for y'all to have taken it in the spring or taken it this last time, especially if you've never taken it before. It is a daunting test. It is a big test. And it can be somewhat overwhelming, especially the first time you take it. So we think before you have to take it as a part of kind of the school's grade for most part, we think it'd be good to take it at least once or twice
Yeah,
to get the hang of it.
it definitely was good to take it.
But anytime you improve your score, it will replace any of the previous ones. So if you improve your math score on the next one, that one will stay, the other one will be replaced. So it'll replace any that you improve.
But if you decline on it, it won't take it.
It takes the highest one out of each section. So if it goes down, it kind of ignores those and just takes the higher ones. Now here, the square root and square cancel, leaving us with x minus 4 is equal to, well, we need to simplify this fraction. Simplify this here. So we can break it up, say second square root of negative 5 over second square root of 2, and we get domain error. Okay. Maybe the negative needs to be down low. No. Let's just say second square root of negative 5 halves. Well, it doesn't like any of them. Maybe it's just the calculator. Let's try the graphing calculator. Second square root alpha y equals enter negative 5 halves. Yes? Enter. Okay.
Did it do this the old day?
Yeah. There's something weird about that number. What is it? Or the answer it gave us. What did it tell, or read the number out? 1 point, what is it? It put an I there, didn't it? I actually is a number. Well, let's actually graph it. So if I were to graph it, I would need to add the 5, yes? Which would really tell us this equation is 2x minus 4, close parentheses squared, plus 5, yes? Where does it cross the x-axis? Nowhere. So this has no real. And the issue is coming right here. I'm going to change the number. Let's say it was square root of negative 4. When we take a square root, we're looking for what times itself is the number inside the radical, yes? Well, what times itself is negative 4? 2 times 2 is that positive or negative? We need it to be. So what would we have for that? Because what's negative 2 times negative 2? Positive 4. Yes. We need 1 negative, 1 positive. But if it's a square root, we're looking for a number times its. So is there any way we can get that? This is part of the reason why we keep getting no real solution, is because we have this square root of a negative. It doesn't work. But there are ways to get the solutions. And we'll learn about them, or the square roots of negatives, on Monday. And for now, there are no real solutions. We will get a solution eventually. Well, that's the end of the square root method. We're going to do a few by factoring, and then that will be the end of 3.3. X squared minus 4x equals 45. If we're solving by factoring or graphing, we need this thing equal to,
0.
so what's the first thing we can do?
Or
Minus 45 from both sides. On the left-hand side, we'd have x squared minus 4x minus 45 is equal to 0. Is there a greatest common factor? No. Two sets parentheses with three spaces. The sign of the third term. If it's positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So here the signs would be positive and negative. They'd be opposite. Now we need to find the factors of the first and third terms. Factors of x squared are factors of 45. 5 and 9, and 3 and. Which one do we want to try first? Okay. Then we can check our middle term. X times negative 15 is negative 15x. Positive 3 times positive x is plus 3x, which gives us negative 12x. So 5 and 9. We check this here. X times negative 9 would be negative 9x. 5 times x is plus 5x, which gives us negative 4x. Is that what we wanted? Now we do have two things multiplied together to equal 0, so one of them must be 0. So either x plus 5 is 0 or x minus 9. What can we do first here? Telling us x is our other one, we would add 9 to both sides, telling us x is equal to. So our two solutions are x equals negative 5 and x is equal to 9. So we type that in. When x is negative 5, we get 0. And when x is 9, we also get 0. So we could have solved this by graphing also. Questions on this here? Questions on anything we've done so far? I'm going to skip over that one and look at this one here. So we're going to do two more, this one and one more, and then we are done for the day. Now this one here says to find the zeros of f of x equals 2x squared minus 11x plus 12. And what we've been doing with solving is we're trying to find out what value of x that will make this function equal what? Make this function equal 0. So we're trying to find the zeros. Kind of makes sense, doesn't it? Trying to find out what value of x will make the function be 0. So we're finding its zeros. That's x-intercepts. So if we're trying to find that, really we're saying that 2x squared minus 11x plus 12 is equal to 0. Now we do have a middle term. We have that 11x, so we can't use the square root method. So we can factor, possibly. In this here we can. Is there a greatest common factor between these three terms? So we'll have two sets of parentheses with three spaces. Our signs. If the third term is positive, our signs are the same and match the sign of the middle term. So the third term, is it positive or negative? If the third term is positive, the signs are the same and match the sign of the middle term.
Oh,
If the third term is negative, then the signs are opposite.
okay.
So if it had been minus 12, it's going to be plus and minus. Since it's positive 12, since the 12 is positive, we look at the middle term to get the signs. Does that make sense?
Yeah.
The only time we look for signs of the middle term is if the third term's positive. Third term's negative, it's automatically opposite. One's positive, one's negative.
Yeah, I just never really, like, I guess, like, explained it to myself, really.
So the best way to think of it is because to get that third term, let me get this color. To get the 12, we're multiplying these two numbers together. So we're multiplying those two numbers together to get positive 12. Well, the only way I can multiply two numbers together and get a positive is if either A, they're both negative, or B, they're both positive. They have to both be the same. If it's negative, one of them has to be positive, one of them has to be negative. That's the only way it works. So if it's negative, they're going to be opposite automatically. Now, when we find the middle term, when we go to check the middle term, we end up doing these two times these two, and then add those two together. Well, if the middle term is negative and the signs are the same, it means we're adding two negatives. If the middle term is positive, that means we're adding two positives. That's why it works that way. That's why I kind of like that method, because it kind of makes it easier a little bit. Factors of the first term, 2x squared. 2 and 1, so we'll just put the 2 in the first one. Factors of 12. Which one do we want to try first? 2 and 6. So which one goes first, 2 or 6?
No, we can't do that.
Because if I put 2 here,
Oh, yeah, the factor.
2 and 2x would have a common factor.
Take that at all.
Yep, 2 and 6.
1 and 12.
So we'd have to put 1 and if we check this here, 2x times negative 12 is negative 24x. Negative 1 times x is negative x, giving us negative 25x.
34.
Yeah, because if we tried switching the 1 and 12, it would indeed give us a greatest common factor. So we have to do 3 and 4. 2x times negative 4 is negative 8x. Negative 3 times x is negative 3x, giving us negative 11 x, which is indeed the middle term we wanted, yes? At this point here, we do have two things multiplied together to equal 0, so one of them must be 0. So either 2x minus 3 is 0, or x minus 4 is 0. So for the one on the left, the first thing we would need to do is minus 2x is equal to, and then we would. So x is equal to 3/2, or 1.5. We get this here. The one on the right, we would. Minus x is equal to questions on this here. That's fine. We have one last one we're going to look at. F of x equals x squared minus 8x. So again, if we're finding zeros, we want to see what value of x is going to make 8 or x squared minus 8x be 0. We can go on and factor this because we can't use square root method because of the 8x. We have a middle term. It doesn't work. But if we factor this, first step would be greatest common factor. Is there a greatest common factor between x squared and 8x? Do they have something in common? X, yes. Because up to this point, we've had some number added to it that prevents x, a variable, from being in common in every term. Here we don't have it. Both of these do have an x in common, so we can factor it out. Because if we factor an x out of x squared, we have x. If we factor an x out of 8x, we just have 8. So that tells us 0 is equal to x times x minus 8. Since we have two things multiplied together that equal 0, one of them must be 0. And for the one on the right, we can add 8 to both sides, telling us x is equal to 8. And well, the other one, x equals 0. That is it. We get this here. And that is it.